All right. In this video, we're going to talk a little bit about internal energy of a system. And so here we're shifting ideas from our point particle system, which has been, what we've been using a lot. The idea that we can take some object and crush it down to a single point and sort of track how it moves. When systems have internal structure to them, like this system I have here of two spheres connected by a spring, we have to worry about whether there are some internal degrees of freedom or some internal energy associated with that system. So take the example of these two spheres connected by a spring moving with a velocity v. If they each have a mass m, then the kinetic energy associated with that system is 1/2 times twice m v squared. But let's instead take a similar system, but now we've compressed the spring. We've attached a massless rope around the center to keep it compressed. The object still is moving with a speed v. And so we can think about it having some kinetic energy, similarly to the previous example, 1/2 2mv squared. But there's something about the internal structure here. There's more total energy. In fact, the kinetic energy of this system is equal to the total energy. The kinetic energy of this system is actually less than the total energy because we have some potential energy associated with the compression of the spring. There's some 1/2 ks squared energy associated with squeezing these two spheres closer together. So we can see that if a system has some structure to it, we have to pay attention to what that internal energy is. Another example might be if you have a system that is, say, rotating. So let's say you have two spheres and they're rotating around their center of mass and they're also moving. This system has structure to it. It has the kinetic energy that you would expect, the 1/2 2mv squared, associated with their net motion. But there is this sort of relative motion that also has to be accounted for in some way. And further, we can think about connecting these two again by springs, and they oscillate back and forth like this. There's some kinetic energy associated with that. So thinking about all of these sort of internal degrees of freedom, whether you have this kind of compression or you have some rotation or some vibration, each of those can contribute to the internal energy of a system that has structure. So we'll have to start accounting for that in some of the systems that we're going to be studying.